Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to discuss dynamic versus fixed IP addresses, since I've had a lot of questions on the channel about that recently. So both LXD and Incus containers, as well as LXD virtual machines and Incus virtual machines, are assigned dynamic TCP/IP addresses from a DHCP server by default. And self-hosted services often require a fixed or static address, which means that if you have a particular container up and running, you want it to get the same address all of the time. And it's my recommendation that these fixed addresses be managed on your router with something called DHCP address reservations. And unfortunately, all routers are different, so I can't give you one way in order to do that. Depending on the brand and model of your router, DHCP address reservations may be set differently. Also, if you're using DHCP address reservations, as I recommend, it's important to be able to back up that router so that you wouldn't lose those assignments when the router is upgraded or when the router crashes and needs to be factory reset. So it's also possible to set a fixed address by configuring it on an individual system. And again, I don't really recommend this, but it's important to understand how to do this, and there are cases where this is a good thing to do. So there are different ways to set TCP/IP addresses. Dynamic Host Configuration Protocol, or DHCP, as I mentioned earlier, is normally configured on your router, and it can be configured on other places as well. So DHCP assigns an IP address, a subnet mask, and a gateway, and optionally it can also assign many other parameters, but we don't want to do a DHCP deep dive today. We want to understand just the basics. So DHCP works by providing an address lease via a range of addresses that is called a DHCP scope. And it tracks which addresses it leases out by the hardware MAC address of the computer making that DHCP request. So you're thinking, wow, a MAC address is a hardware address. How is it that we can have a MAC address on virtual devices like Incus and LXD containers? And the answer is it's granted a virtual MAC address, but when you launch a container and bring it up, it will always have that hardware MAC address every time it boots, and that's what allows the DHCP server to track and understand which container it is so it can assign an address to that particular container. So Ubuntu uses a program called netplan to configure network controllers for either fixed or DHCP addresses. And I've covered netplan on the channel before, and we're going to cover it this time again, both in setting a DHCP address and also setting a fixed or static address. And Ubuntu also has the nmcli and the IP commands that can configure its controllers, but this is not the recommended method. So in this tutorial, we're going to talk about how to set addresses in various ways. Here we are on an Ubuntu 2204 desktop, and this desktop happens to be an Incus virtual machine. So if you click on the upper right hand corner, you'll notice that it says Wired Unmanaged. And we could click on it, or we can go into settings. When we go into settings, if we select network, we don't see anything here other than the VPN not being set up, and there's no network proxy, but we're not actually seeing a network device. However, we do have a network configured, and we can verify that by opening a terminal and doing an IP space A. And here you can see that we have device ENP5S0, and it's getting an address on my main LAN of 172.16.1.94. The other thing you can do is you can do a sudo apt install on net-tools, and we can provide our sudo password. And after providing our sudo password, you can see that it's already installed on my system. And if I do an ifconfig command, we get the same results, except it's formatted a little bit more nicely. We can see device ENP5S0, and we can see the IP address of 172.16.1.94. So since we're actually getting an address and we can see an Ethernet device, then why is it that when we click up here, we can see that it says wired unmanaged, and when we go into the network configurations, we can't see those devices? And part of the reason for that is that we might not have Network Manager installed, which provides that GUI interface, and so we would do a sudo apt install network-manager. But here you can see that on my system, I already have Network Manager installed, but I still don't have GUI control over my network configuration. This is actually pretty easy to fix, and we do that with a program called netplan that's used to change configuration in Ubuntu. So we're going to do a cd over to /etc/netplan and do a ls. Now over here, we may have one or more files. You can feel safe in deleting all of them. Basically, the format of a configuration file is it ends in YAML and it begins with a number. The number indicates the order of execution if there's more than one file. So I'm going to do a sudo nano 10-lexc.yaml, and it will bring me into this program, into this configuration file, which is really very simple because it just says version 2 of the YAML file. It's got an Ethernet, which is called ENP5S0. It has DHCP set to true, and then it says that the DHCP identifier for uniqueness is the hardware MAC address, which is the default anyway. So we're going to go ahead and clear this file out, and then we're going to put our own file in place of it. And that file will be pretty much the same. The only real difference in it is that we are going to have the renderer equal to Network Manager. So the Network Manager renderer is the renderer that deals with the GUI. The default Network Manager otherwise is something called Network D, and it doesn't know how to configure the GUI. So we'll do a Control-O and enter to write the file out, and a Control-X to exit the nano editor. Now normally at this point in time we could go ahead and apply that file, but I'm aware of the fact that the program netplan that is used to apply this file also likes to have the virtual switch installed. So we're going to do a sudo apt install open vswitch -switch. So the open virtual switch is what allows us to do our bridges that we've done on the channel before when we created the device called bridge 0, and it's just that it likes to see that in there for netplan. So we'll do a sudo netplan apply now that we've installed vswitch, and we'll get a prompt back. And if you noticed in the background, it immediately refreshed the screen. It says we have a wired connection and it's connected. If we click in the upper right hand corner, it does not say unmanaged anymore. This time it says wired connected. And if we click on the gear, it'll go into the configuration. It'll list out things like our default route and our DNSs, and then we can go over to IPv4 and change to automatic versus manual and make all of our configuration changes. But this video is not going to focus on the GUI interface. Instead, we're going to focus on the command line interface. So I'm going to go ahead and cancel out of this and cancel out of the network control panel here. and we'll move on to the next section. Before we move on from netplan, let's go do a sudo 10-lxc.yaml, which was the name of our netplan configuration file on this particular system. And this time, I'm going to go ahead and clear out all of the data in this file once again. And we went from the very simple example to a little bit more complex example, but I'm going to show you how you would set up a static address with netplan. And so the static address file would look like this. Again, we have the version 2 of the YAML file. We have the network manager is the renderer. And then we have ENP5S0 is the name of the Ethernet controller. And this time we have DHCP4 is set to false. And then I put up a particular static address that I know is free on my system. You want to make absolutely sure this address is free because it's going to set this machine to that address. So I have 172.16.11.11/16, which is the subnet mask. That's equivalent to 255.255.0.0. On your system, you might be using 192.168.1.140/24 as an example. Now, one of the things that's important about this address is that you get that subnet mask correct, and in your case, it's generally going to be a 24. Then below that, we have routes, and this is the default route because it says routes to the default via 172.16.0.1. This address is the address of my router, and that address tells the system how to get out onto other networks, or more generally, how to get out onto the public internet. And then finally, we have name servers addresses, and I've got 1.1.1.1 and 1.0.0.1, and those are the primary and secondary addresses for Cloudflare, which is one of the DNSs I typically like to use as public DNSs anyway. So let's go ahead and do a Control O and enter to write that file out, a Control X to exit the editor. And before we do this, we'll go ahead and do an if config, and we can see that right now we have the address of 172.16.1.94. Let's go ahead and clear the screen and do a sudo netplan apply. And now let's do another if config. And now we have 172.16.11.11 as our address. The Network Manager program also has a CLI all of its own, and so we can clear the screen and we can do an NM CLI, short for Network Manager CLI, and say connection show, and that will go ahead and show you that we're currently operating under a netplan file for ENP5S0, which is Ethernet, and it's talking to device ENP5S0. We can also do the command nmcli device status, and it will tell you that it is connected. And then since it doesn't say unmanaged, we know that it's a managed connection. And it also says that the loopback device, LO, is an unmanaged device. We can also issue a command nmcli device show ENP5S0, and that gives us all kinds of information about that particular device, telling us, if we spread the screen out here a little bit more, it can tell us things about its default routes, and it tells us about its gateway, which here seems to be, yes, right there, 172.16.0.1. It gives us what its current address is, and so on. So we can get out of that with a Control Z. If I specifically wanted to see just my DNS servers, then I could issue the same command we just issued, and pipe that over to grep where I search for IPv4.DNS, and it tells us that my two DNS servers are 1.1.1.1 and 1.0.0.1. There is also a series of IP commands to know, and you've probably already seen IP space A, which just says give me information on all the devices on all the network devices on my system, I should say. Then we have IP space route, which will give you your default routes. And then if we look at IP space -S link, that gives you statistics on all of your links. And if we do the same command, IP-S link, where we say list ENP5S0, then it gives us just the statistics on the ENP5S0 device. You can also use IP to list out all your IPv4 addresses on your interfaces. So IP space -4 space ADDR, and there you go. We have the IP addresses for my loopback adapter and my ENP5S0 adapter. One thing that's real helpful is there is a command that you can issue via ifconfig, and it's basically a curl to ifconfig.me, and that will give you a return address that is the address of your WAN interface, or what this particular system believes that your WAN interface is. So again, my recommendation is to use netplan to change your network configuration, and also to use DHCP and to use DHCP address reservations. So that being said, let's go back in and do a sudo nano on our netplan file. And when we come in here, I'm going to go ahead and change DHCP4 equal to true. And then I'm going to delete the rest of the lines, since DHCP will provide an address to this system, and it will also provide the default route as well as the name servers. So after deleting all those, I can do a Control-O and enter to write the file out, and a Control-X to exit the nano editor, and I simply do a sudo netplan apply, and then I can do an ifconfig, and we see that we're back at 172.16.1.94, which we got from the DHCP router. So I guess the long and short of this is DHCP is wonderful, and make it work for you. So in this particular example, and I mentioned earlier on that all DHCP configurations are different because all routers are different. But in this particular case, you can see that I have a gateway IP subnet that starts out defining this particular network. It says what that gateway IP is, and then I work down here and they have the DHCP server configuration. So in my case, I have my DHCP scope set from 172.16.1.60 all the way out to 172.16.1.250, which means that when DHCP assigns an address to a system that boots up requesting an address, it's going to be an address granted to it in this particular range. And then if I click on show options in my DHCP management, I have some other things set down here. Notably, I have custom DNS servers, which is something else that DNS or DHCP can do. And so I have a primary and secondary DNS on my local area network, which happen to be some pie holes. I've had some videos about that. And then I have a tertiary and quaternary DNS servers, which just happen to be Cloudflare. So here we are on my Ubiquiti Unify UDM Pro router, and I've located the system called Desktop, which is our Incus VM. And here you can see that it still thinks it's running at 172.16.11.11, so it's lagging behind just a little bit. But we know that it's now set to DHCP because that's the last thing that we did with it. So I'm going to go under settings here, and I'm going to scroll down, and it says fixed IP address. So I'll go ahead and put a check mark in that, and I'll go ahead and set that fixed IP address to be another number. Now it could be within the DHCP scope, but it can also be anything in my valid network range, which could be outside of the DHCP scope. So I'll go ahead and set that address to be 172.16.13.13, and then I'll say apply changes. As a reminder, let's go ahead and do an if config, and we see that our current address is 172.16.1.94. So let's go ahead and release that address back with the command sudo dhclient -v for verbose -r for release. And it says killing old client process, and then it goes ahead and releases that address of 172.16.13.13. Let's go ahead and do an up arrow and just do a dhclient -v, and here you can see that it said that it bound it to 172.16.13.13. So again, this gives us one place to go. We can go to the router and we can manage all of our DHCP address reservations from up here. Otherwise, the alternative is that we would have to go to each of our individual systems and manage static addresses from them, and that produces a high degree of possibility for error, and that you may duplicate an address or use an address that another system is using. So in summary, in this tutorial we learned that TCP/IP addresses can be either assigned as fixed or via DHCP. Self-hosted services usually require fixed addresses, and a DHCP address reservation is my recommended method. We learned how to use netplan and also the IP command to configure network interfaces in Linux. And understanding the basics of IP addressing is critical to having a properly configured home lab. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.